Previously, we covered the linear regression method, which serves as a mean to validate the linear relationship between two variables and also to determine the slope and the uncertainty on the slope of the linear best fit line, or simply the regression line. However, when it came to determining the uncertainty, whether on the slope or even on the y-intercept, the mathematical approach that we have followed was actually time-consuming and prone to errors related to the numerical calculations. For that matter, we are going to revert to a much simpler method that is built in Microsoft Excel, where you can apply the least square fitting method in a very simple manner in order to determine the constants of the regression model, in addition to determining the error on slope and the error on the y-intercept. So let's start by considering that we have on that Excel sheet the following data set for two different parameters, the data for the magnetic field and the data for the electrical current. And the purpose in that case would be to determine the slope of the magnetic field versus the electrical current, as well as to determine the y-intercept and the error on slope, as well as the error on the y-intercept. So how can we manage to do that on Excel? Now, before we start tackling the solution for that part on Excel, first off, we are going to be plotting the magnetic field versus the electrical current, so we are going to be highlighting both columns. Then over here, we are going to click on Insert. Then we are going to click on Scatter. Now, in that part, you can choose any scattering pattern that you want. I'm going to be choosing this one. So as we can see on that graph, we have a linear relationship between the magnetic field and the electrical current, meaning that the data set for both of the magnetic field and the electrical current, they actually reside on a straight line. So over here we are validating the linear relationship that exists between the magnetic field and the electrical current. Now, a very simple method which can actually enable you to obtain the y-intercept and the slope of that straight line would be to click on that straight line, then to right click on it and to select Add Trend Line. Then at the bottom over here, you are going to be selecting Display Equational Chart, and you are going to be selecting Display R-squared value on chart. Now, what do we mean by the R-squared value? The R-squared value is none other but the correlation coefficient squared. So if you remember, the correlation coefficient, it was actually an indication of how strong a linear relationship between x and y is. So the closer r is to +1 or to -1, that would imply that we have a strong linear relationship between x and y. So over here, r squared is none other but the correlation coefficient squared. Then over here, we have the equation of a straight line, y equal ax plus b, where the slope is none other but 1.1823, and the y-intercept of that straight line is none other but -0.0092. So as we can see, that method over here, it actually enabled us to determine the y-intercept, the slope, and the correlation coefficient of that straight line. However, we are still missing the error on slope and the error on the y-intercept. For that matter, we are going to be referring to another method on Excel which can enable us to determine altogether the y-intercept along with the slope, along with the error on slope and the error on the y-intercept. As you know, on Excel there are multiple built-in functions for different purposes, and one of these functions is actually called the LINEST function. The LINEST function is actually based on the least square fitting method, meaning that it uses the linear regression model that we have studied before in order to determine the characteristics of a straight line. So how can we apply the LINEST function in that case? Anywhere on that Excel sheet, we are going to be highlighting 4 different cells. So anywhere, we are going to highlight 4 different cells, and then we are going to click on equal. Then after clicking equal, you are going to type in the LINEST function letters. So you start by typing in L-I-N. So as we can see, as we are typing in that function, multiple functions, multiple possibilities, they are going to show up right beneath it. And we are going to select the one which is appropriate in our case, which is none other but that first function, which is the LINEST function. And then the parenthesis would open. So if we look below, once the parenthesis open, we have multiple parameters that we need to fill in between these parentheses. So first off, we have the known y's, comma, followed by the known x, comma, followed by a constant, comma, followed by stat, and then you close the parenthesis. Starting with the known y. Over here, they are asking you to determine the slope of the magnetic field versus the electrical current, meaning that the magnetic field would be the y variable, whereas the electrical current would be the x variable. So over here, the known y's imply that you are going to insert all the y values that you have, which are none other but all the magnetic field values. So over here we are going to select that entire column for the magnetic field. Then you click on comma, followed by the known x. The known x, which is none other but the values of the electrical current in that case. So also you are going to highlight that entire column, followed by a comma, and then we arrive at that constant over here. That constant is a value that determines how the y-intercept of that graph should be treated. For instance, if you force that constant to be equal to 0, therefore you are assuming that the straight line passes by the origin, and therefore you don't have any y-intercept. However, if you set that constant to be equal to 1, therefore the y-intercept is going to be calculated normally. So in that case, you always have to equate the constant to 1. You always have to choose 1 for that constant, instead of assuming that the straight line is actually passing by the origin and therefore omitting the existence of a y-intercept. So over here we are going to choose 1, followed by a comma, and finally we arrive at the last parameter in that function, which is stat. So what do we mean by that parameter in that case? Stat is actually a value that determines whether you want the LINEST function to calculate or to provide you with additional regression statistics, like the error on slope and the error on the y-intercept or not. Meaning that if you equate the stat parameter to be equal to 0, therefore the LINEST function would only provide you with values for the slope and the y-intercept. Whereas if you equate stat to be equal to 1, therefore you are asking the LINEST function to provide you with additional regression statistics like the error on slope and the error on the y-intercept. So for that parameter, you are always going to equate it to 1, because we are in need of determining the error on slope and the error on the y-intercept. So over here we are going to choose 1 for stat, and then we are going to close the parenthesis. Now here comes the tricky part. So after inserting the LINEST function and after inserting in all the parameters within the parentheses, now you are not going to click on enter, but instead you are going to click on Ctrl plus Shift plus enter. So right after you plug in your function and you insert all the parameters within that function and you close the parenthesis, you are not going to click on enter, but instead you are going to click on Ctrl followed by Shift followed by enter. And as you can see over here, we have all 4 cells being filled with values. So the first value over here is going to be pertaining to the slope of the magnetic field versus the electrical current. Then that value over here, negative 0.091, is going to be pertaining to the y-intercept. Then you have that value over here, 0.018, is going actually to be the value for the uncertainty on slope or the error on slope. And finally, that value over here, 0.051, is going to be none other but the value for the uncertainty on the y-intercept. So as we can see over here, by using a very simple function, the LINEST function, and by plugging in all the needed parameters, we have actually obtained in a very simple manner the values for the slope, the y-intercept, the uncertainty on slope, and the uncertainty on the y-intercept. However, here you have to keep one thing in mind, that the values for the magnetic field, they are actually in millitesla, which is not an SI unit. And whenever you apply the linear regression method, you have to make sure that you are converting your values to SI units. So over here, there are 2 methods that you can adopt. The first one would be to actually multiply each value by 10 to negative 3, and therefore you have actually converted all of your values to SI units. And the second one would be to actually convert all these values over here to SI units before you actually determine the values for slope, the y-intercept, etc. So let's suppose that we haven't determined these values yet, and we want first to convert the values for the magnetic field to SI unit. So how can we do that? Basically, what we need to do is we need to multiply that entire column by 10 to negative 3. So over here, we are going to be writing down the value by which we need to be multiplying that entire column. So we start by writing equal 10 to power negative 3. And then we click on enter. Then you are going to be copying that cell. So you copy that cell, then you are going to highlight that entire column by which you want to multiply by 10 to negative 3. Then you right click on it, then you select paste special, and then you go down at the bottom of that page, and also you select again paste special. So right at the bottom of that page you have the option paste special that you need to click on it. So as we can see over here, we have multiple options. We are going to be choosing the multiply option. So in the operation window over here, you are going to be choosing the multiply option. It basically means that you want that value to be multiplied by that entire column, which has been highlighted. Then you click on OK. So as we can see now, our values, or the values for the magnetic field, they have been converted to SI units by multiplying them by 10 to negative 3. And then you can apply the LINEST function in order to determine the slope and y-intercept, etc. So over here again, we are going to be highlighting 4 cells. You are going to click on equal. You start by typing in the LINEST function, and then you choose it. So the parentheses would open. You start by entering all the y values. So you are going to highlight that entire column, comma, followed by the x values, comma, followed by 1 for the constant, comma, followed by 1 for stat, and then you close the parentheses. And again, over here, you are not going to click on enter, but instead you are going to click on control, followed by shift, followed by enter. So as we can see now, our entire values have been converted to SI units. So over here we have 0.00118 for the slope. We have negative 9.1 times 10 to negative 6 for the y-intercept. Over here we have 1.8 times 10 to negative 5 for the uncertainty on slope, and over here we have 5.1 times 10 to negative 5 for the uncertainty on the y-intercept. And that would be it regarding applying the linear regression on Excel by using the LINEST function.